I'm going to go over the answers to the Hardy-Weinberg intro worksheet. There's two formulas for Hardy-Weinberg. One of them is p squared plus 2pq plus q squared equals 1. In that formula, the individuals that are p squared are those that are homozygous dominant. 2pq represents those that are heterozygous, and q squared represents those that are homozygous recessive. The other formula is p plus q equals 1, where p represents the dominant allele and q represents the recessive. To solve these problems, the trickiest part is probably identifying what is the information that you are given. Question number 1 tells me I have 200 mice. 8 have short tails. Short tails is recessive. The only way to get a short-tailed mouse would then be a homozygous recessive mouse. So I know that the value I'm given, 8 out of 200, must be q squared, because the only way to have a short-tailed mouse is to be homozygous recessive. If I put that in my calculator, I get that q squared, 8 divided by 200, is going to be 0.04. From there, I can solve for q. To find q, I would do the square root of 0.04, which would give me then 0.2. To solve for p, I will use my formula p plus q equals 1. So something plus 0.2 equals 1. I'll subtract 1 minus 0.2 to get an answer of 0.8. To find p squared, I would do 0.8 squared, p squared, 0.8 squared, which would be 0.64. And then to solve for 2pq, I would multiply 2 times p times q, which will give me 0.32. Question number 2, again, figure out the information that you are given. There's 100 owls. Out of 100, 64 are dominant. That's a little bit tricky because I don't know if they are homozygous dominant, p squared, or if they are heterozygous, and most likely they are a combo of the two. So that number, 64, is not going to help me initially because I don't know exactly what they are. However, if 36 are recessive, I know that in order to be recessive, you must be homozygous recessive. So I then know that 36 out of 100 are recessive. They are homozygous recessive. So that value is then my q squared. I'm going to solve for my other variables before I go back to the question. I'm then ready to figure out, well, what is q? Q would be the square root of 0.36, aka 0.6. From there, I could figure out that p and q have to add up to 1, so 1 plus something will give me that 0.6. I'll do 1 minus 0.6 to get a p-value of 0.4. And then I could solve for p squared, which would be 0.4 squared, which is 0.16. And then I could solve for 2pq. 2pq would be 2 times 0.6 times 0.4, which is 0.48. I'll then refer back to my question, the frequency of the dominant trait. How many of them are dominant? Well, my question said 64 of them were dominant. So 64 out of 100, or 0.64, were dominant. The frequency of the recessive allele is asking me for either P or Q, and it's asking me for the recessive one, which is Q. And the frequency of my heterozygotes are here, 0.48. Question number 3. In humans, attached earlobes are caused by 2 recessive alleles. Free earlobe is dominant. The frequency of the recessive allele, my recessive allele, is 0.7. So that is my value for Q. The word allele tells me that it must be either P or Q. So my recessive allele is 0.7. To find my dominant allele, I know that they must add up to 1. So therefore, I know that the dominant allele must be 0.3. I'm then ready to solve for each of my phenotypes, what the organisms look like. Big R is P squared, meaning 0.3 squared. Little r is Q squared, which would be 0.7 squared. And then my heterozygote would be 2PQ, meaning 2 times 0.3 times 0.7. Question 4. The homozygous recessive make up 9%. So 9 out of 100 is my Q squared. From there, I know the square root of 0.09 would give me Q. So Q is therefore 0.3. Q represents the recessive allele, which is small a. So that would be 0.3. I know that P plus Q add together to give me 1. So these two numbers together add to give me 1. Therefore, big A must be 0.7. Question 5. In a population of 3,000 fruit flies, 270 have white eyes. White is recessive, so I know my 270 is my homozygous recessive, represented by Q squared. So I know Q squared is 270 over 3,000, which is 0.09. I then can find the square root of that to find Q. So Q would be the square root of 0.09, which is 0.3. From there, I know that P plus Q must add to 1, so P must be 0.7. P squared would then be 0.7 times 0.7, meaning 0.7 squared, which is 0.49. And then I can solve 2PQ, which would be 2 times 0.7 times 0.3, which would give me 0.42. So to answer the questions, what is the allelic frequency for the red eye allele? Well, I am being asked about the allele, so that's either P or Q. And it is asking me about red. Red is dominant, therefore that first question is asking me for P, 0.7. What percent would be heterozygous? Heterozygous is 2PQ, so I could say 42% or 0.42. In AP world, that's the same answer, 0.42 or 42%. And then lastly, what would be the number of red-eyed flies? Well, I know that 270 of them had white eyes, and there's 3,000 total. So I can just subtract 3,000 minus 270 would give me 2,730 then have red eyes. Question number 6. Population contains 16 animals with red, 34 with blue. Blue is dominant. I will pretty much always start with the recessive. So I know that Q squared is 16 over the total. There's 16 and 34, so meaning that there's 50 total. So my Q squared value is 0.32. So again, always figure out what are you given with. If you're not given P, Q, or Q squared, you'll need to find it. That's where you have to start. From there, I'll go through and solve. Q would be the square root of 0.32, which is 0.57. P and Q have to add together to give me 1. P squared would be 0.43 squared, which is 0.19. And then lastly, 2PQ, I would multiply 2 times 0.43 times 0.57, which is 0.49. Sometimes I find it easier to just do all the math and solve all the math and then take a look at the questions. Frequency of the red allele. Allele means it has to be either P or Q. In this case, red is recessive, so I am looking then for Q, which is 0.57. The frequency of the blue allele, again, I'm looking at either P or Q. Blue is dominant, so I am looking at P, which is 0.43. And then the frequency of heterozygotes is 2PQ, so 0.49. Question number 7, Hardy-Weinberg equilibrium. Equilibrium means that there's no changes occurring, meaning if I have this frequency of red now, many years later, it would be the same exact frequency. There is no change, no evolution occurring. So in order for there to be no evolution, there's those 5 requirements. It's large population, random mating, no mutation, isolation, no natural selection. You can reference those in the notes, but equilibrium means that they are not changing.